Hi friends, welcome to Eco Engineer. Today we discuss about bridge rectifier or the full wave rectifier without center tap transformer is also called as a bridge rectifier. The operation of a bridge rectifier, the construction of bridge rectifier, and input and output waveforms of a bridge rectifier. Let's go to the topic. Here, the bridge rectifier is nothing but full wave rectifier without center tap transformer is also called as bridge rectifier. The bridge rectifier circuit frequency used for electronic DC power supplies is a full wave bridge rectifier. In full wave bridge rectifier, four diodes are used as shown in the figure. This is diode D1, diode D2, diode D3, and diode D4. Here this is primary coil and this one is secondary coil. The primary coil we have input voltage, AC voltage or sinusoidal signal. The across this diodes and across load resistance RL, the output can be formed which is like unidirectional voltage or DC voltage. This is the construction, the basic structure of a bridge rectifier or full wave rectifier without a center tap transformer. Without center tap transformer is called as bridge rectifier. Now go to the topic. During the positive input of cycle, terminal M of the secondary transformer is positive. Here, the terminal M of the secondary transformer is positive, while the terminal N is negative. Here, terminal N is negative, terminal M is positive. In this situation, diodes D1 and D2 are forward bias or on position. Here, when the diode the D1 and D3 are forward bias because of the secondary transformer of the terminal M is positive, the secondary transformer of the terminal N is negative. In this situation, the diode D1 and D3 are in forward bias or in condition mode or in on position or in close. They conduct, whereas diode D2 and D4 are reverse bias or in off position or in open circuit is called, then do not conduct. D2 and D4 do not conduct. When the D1 D2 are forward bias, they conduct the flow of current through D1 and D3. Here, a current flows along M, A, B, C, E, F, N as shown in the figure. Orange arrow marks here. M through A and B and S, B and C across load resistance RL through C and also E and also F and also N. This is the closed loop of current flows across the diodes D1 and D3, while the voltage drop across the load resistance RL. During the negative off cycle, when the positive off cycle, bridge rectifier during positive off cycle, diode D1 and D3 are a forward bias condition. Here D2 and D4 are reverse bias condition. During the negative half cycle, the terminal N of the secondary of transformer becomes positive, while the terminal N becomes negative. M becomes negative. Under the situation, when the negative half cycle, the terminal M becomes negative and the terminal N becomes positive. In the situation, the diode D2 and D4 are forward bias condition, and D1 and D3 are a reverse bias condition. Okay, here when the reverse bias there is an off mode condition. When the forward bias they are conduction mode or they are in a closed circuit. Okay, that does not conduct. Now current flows along N, F, B, C, E, A, M as shown black arrows. Here, you have to see that the current flows along N, F, and direction N, F, B, and also along the load resistance RLC and the E, and along A, M is the flow of current across the load resistance RL. Here, during this positive half cycle bridge rectifier circuit diagram, this is a negative half cycle bridge rectifier circuit diagram. When the positive half cycle D1 and D3 are forward bias condition, when the negative half cycle D1 and D2, D2 and D4 are forward bias condition. Here during the positive half cycle, diode D1 and D3 are diode D1 and D3 are in forward bias. D2 and D4 are reverse bias or open. During the negative half cycle, diode D1 as reverse bias, diode D3 as reverse bias. In the negative half cycle, D2 and D4 are forward bias. Okay, now go to the input and output waveforms of bridge rectifier or full wave rectifier without center trap transformer. Here we have to see that this is input voltage, the sinusoidal signal or the AC signal or AC voltage. This is a peak value, this is negative peak value, this is input voltage. Here this is when the output during the positive half cycle, this is a positive half cycle, this is negative half cycle, this is positive half cycle, this is negative half cycle, this is positive half cycle, this is negative half cycle. When the positive half cycle during the output during the positive half cycle, nothing but when the positive is positive, the positive is positive across this, the positive is positive across this. Okay, positive, positive. When input voltage, when also the again input voltage is given, the output during the negative half cycle, nothing but when the output is during the negative half cycle, the negative half cycle is also conductance, the negative half cycle also conductance, the negative half cycle also conductance. Hence, the total to the output during the positive half cycle and the output during the negative half cycle, both the two outputs can be combined. The total output is nothing but this wave. Okay, this is the input and output waveforms of a bridge rectifier or full wave rectifier without center tap transformer. Okay, guys. When the positive half cycle, the D1 and D3 are forward bias. When the negative half cycle, D2 and D4 are forward bias. D1 and D3 are reverse bias. Hence the conductance, a negative half cycle can be conducted positive half wave in the output waveform. This is the full wave of full bridge rectifier, full output, total output of a bridge rectifier waveforms 0 to pi, pi to 2 pi, pi to 3 pi, 4 pi, 5 pi, 6 pi. Okay, this is the peak inverse value. This is the input and output waveforms of a bridge rectifier. Thank you. Thank you, friends.